Dear students, today we will study single dimension arrays in Java. Before that, let us see what happens in this case. For example, for I is equal to 1, I is less than or equal to 10, I plus plus. Say I starts from 1, goes up to 10. As you know, first time I is 1, we get condition is satisfied, we come here, we accept the first number over here. Then when it goes up, I plus plus, I becomes 1, becomes 2, it is once again satisfies. So once again new value is accepted and it overrides the existing value in M. As a result, when the loop completes, when the last number will be stored in M, all the previous 9 numbers what we have entered is lost. See, we cannot able to store more than one value in a variable. But if I declare 10 variables to store 10 different values, my program will be very lengthy. To avoid this situation, we declare a single variable but which can able to store more than one value. That is known as an array. An array is a structured element in the memory to represent number of same type of data with the help of a single variable. For example, instead of just writing intm as a variable name, I write intm opening and closing bracket is equal to new int of 10. So m is a variable, it is an array variable of integer type which can store 10 values now. Let us see how it works out. See, m is the array name. We have different position in it from 0 position till the 9th position. Array name is same m, but position is changing. This position is known as either index or a subscript. Like in a sheet of paper, we draw so many rows and we enter names in different rows. No? In a classroom, we give a roll number 1, 2, 3, 4 like that. Same way, array name is same, but the subscript changes, array index changes. As a result, we can store more than one value in a same variable because position in an array will change. This is known as a single dimensional array, which in this case can store 10 numbers. Right? Hope you understand the concept of an array. These are the elements, these are the values, these are different positions. Variable name is same, positions are changing. Let us see the double dimensional array later. Let us concentrate today on single dimensional array. Now, here, if I want to declare an array of integer type, it is int m bracket is equal to new int of 10. Size can be anything as you wish. If you want to make it 100, just mention 100. Same way for float or char or a string or any primitive types, you can declare an array like this. Or for non-primitive also, you can do it like that. So, now let us see how to initialize an array. It is declaring an array. Here we are just declaring and saying that I need to store 10 numbers in this variable. So that much memory. For example, here is an integer array. We know that to store number integer we need 4 bytes. So 4 into 10, continuous 40 bytes are allocated for this array. Whereas if it is a float also 4 bytes, whereas char only 2 bytes, 2 into 10, 20 bytes are allocated for it. So like that, depending on the size of a element type, data types, into the number of elements you want to store, that much space continuously is allocated for an array. Now, let us see how to initialize an array. For example, see, int m square bracket is equal to, instead of declaring a size, directly you can initialize a value like this. When you initialize it like this, automatically size is decided depending on the number of elements present in it. Let us see how it works. Public class name, public static void main, string args is optional. Let us see how to use it later, this string args part. See, inti comma sum semicolon sum is equal to 0. Actually, no need to put semicolon here. You would have put equals 0 directly over here. Then int m square bracket See, array is declared 2, 3, 4, 5, 6. So array is declared with 5 elements in it. So first element in 0 position, the last element is there in the 4th position. Right? Index always starts from 0. But there is a variable like a length. To know the length of this array, I can just say that variable array name dot length, no bracket. So that how many arrays are stored in it, that size is taken into n variable. We can use it. For example, he declared an array or initialized an array with 5 elements. Since he knows that there are 5 elements in it, for I is equal to 0, I is less than 5, he says, yes, 0 is less than 5. Sum is equal to sum plus m of 5. Sum is 0 in the beginning. M of I is 0 first time. See, in 0 position what is there? 2 is there. That 2 is added to sum, so sum becomes 2. The loop continues here itself. I becomes 1. Then next number is added, next number, so that all the numbers are added. When I becomes 5, the condition is not satisfied. This line will not execute. It comes down and print the sum of the array elements is equal to plus sum. It displays the sum of the elements over here. I feel instead of writing I is equal to 0, I is less than 5. In this we can generalize it by saying I is equal to 0 semicolon, I is less than m dot length. Whatever we learned here, no, that we can directly use it over here. That by chance the size changes, then we will not have a problem over here. Make sure that it is less than the length of an array, not equal to the length of an array, because index starts from 0 like our string concept here. But that is not a bracket here, it is not a function, it is a variable. Okay, you understood how to declare or how to initialize an array and how to use it. Similarly, you can initialize even a character array. Same program, character array is initialized. See, character should be enclosed in single quotes. Characters are enclosed in single quotes. Then the character of the array elements are, that message is displayed. Once again, we know that there are 8 characters. So I is equal to 0, I is less than 8. Otherwise, if you want to write like this, also fine. I is equal to 0, I is less than m dot length. Array name is m dot length. I plus plus is same. Only this part you can change. System dot out dot println m of I. M of I is the position. That position, one by one, all the characters are printed. See the example. You will be taking the program like this. Then you will compile. Once the compile, no syntax error. Then right click on it. Click on this main part. When you click on the main part, this box will come because we had the string args inside. By chance, if I have not done the string args over here, then this box will not come. Directly the output will be displayed. So if you can avoid this now, so no, you don't have to type once again or press OK button once again. Because array is like that, you can initialize a character array. Because each character should be enclosed in single code and you can use a length. Now, here, let us learn how to accept an array in a BlueJ method, as I was telling before. Class sample, public static void main, int, see, not string args now, int m square bracket, int I comma sum is equal to 0. For I is equal to 0, I is less than 5, I plus plus. We are assuming that there are only 5 elements in it. So that is better option. As I said, I is less than m dot length may be better option. Now, sum is equal to sum plus m of I. The same previous program, but he is not initializing an array, he is accepting in a BlueJ method. So, first 5 elements of that array is summed. Then it comes and print the sum of it. Compile, no syntax error. Then right click. When you click on this now, you get a box. In this box, you enter at least 5 numbers. More than 5, fine. Because it takes the first 5 numbers and sums and gives me the answer. But if it is less than 5, an index out of bound error can come. That is the reason to avoid that. You better write them at least 5 elements you enter. then press OK button. You can see that the sum of all these numbers are displayed over here. So this is the way it works out. As I said, make it as I is less than m dot length, then we will not have a problem. Whatever the number of elements they enter, all of them will be summed. So this is the BlueGen method of accepting it. See, always use write string or guess. This time we have done int m square bracket. That you can accept a value. If it is a character, now we should enclose a single code. If it is a string, you should enclose them in a double code. Now, let us see some useful programs in this chapter. Write a program to accept 10 different numbers in a single dimensional array. Display sum of all the numbers which are divisible by either 3 or 5. Let's accept 10 different numbers in a single dimensional array. So, you need to declare an array of size 10. Then, sum of all the numbers which are divisible by either by 3 or 5. So, let us see. Public class sum. Public static void main. Scanner object. See, array is declared. After declaring an array, loop starts. I is equal to 0, I is less than 10, because we want to accept 10 numbers. So, the message, enter the number in the cell. We accepted that number, m of I is equal to in dot next int. We accepted a number. Means 10 times the loop repeats. From 0 to 9 position, we accept together 10 numbers. After accepting all of them, the condition is we want to display sum of all the numbers which are divisible by either 3 or 5. So, see, I once again start from 0 less than 10. First time I is 0. In the 0 position, if when you divide by 3, if the remainder is 0, or when you divide by 5, the remainder is 0, means it is 0 by 3 or 5, then s is equal to s plus m of 5. That number, whichever is divisible by 3 or 5, for example, 33 divisible by 3, so the remainder here, right? So that is added. Or in this case, 55 is divisible by 5, so that is added. 66 is divisible by 3, that is added. Any one, if it divides by either 3 or 5, then you add it to s. See, s is 0 in the beginning. The loop continues. The sum of numbers is equal to s. So it displays the sum of it. Hope it is clear how a sum of array values can be taken with some conditions over here. It is a very simple program, right? Only thing that we know how to accept the elements now and how to extract one by using a loop like this, because index will change, variable name is same. Now next program, accept 10 different numbers in a single dimensional array, display the greatest and smallest number of the array elements. So import Java class public static void main scanner common lines. They want to know minimum and maximum of 10 numbers. So array is declared. Loop starts, accept 10 numbers. See, till here it is more or less same for arrays. Then let me assume the first number is minimum as well as maximum. Where the first number? It is there in m of 0 position. So max is equal to m of 0. Same way min is equal to m of 0. We assume the first number is maximum and as well as minimum. Now the loop starts once again to extract each and every number and check whether it is greater than the max. See, we once again start from 0, not necessarily start from 0, because already 0th value has been taken as minimum and maximum. We can start from 1 actually. If m of I position, first time it is 1, greater than max, the new position value, if it is greater than max, means what happens? Max should be, this number should be taken as a max. So max is equal to m of I. Or by chance, in this new position value is less than whatever is there in min, means the new number is minimum, then min is equal to this number. So it is a very simple logic. First we take the first number as maximum as well as minimum. Further the loop starts, next number we extract from the array, checks is it greater than the maximum. If so, we change the maximum as that number, or if that number is less than the minimum number, we take that the new number as a minimum number in min variable. The process goes on the remaining times. Once it's over, once you come out of the loop, biggest number will be there in max and smallest number will be there in min. You can write and practice. Small mistakes you may do and you may lose marks. You can avoid it. It's a board question in 2007. Very simple logic, 15 marks program is this. Right? One more important program starts now. Go to the question. See, we have to accept 10 numbers. We have to accept 10 numbers. After accepting 10 numbers, we have to accept one more number and check whether that number exists in this list or not. We take 10 numbers and take one more number and check the new number entered is there in the list or not. So, it is actually a searching. We have two types of searching. One is a linear search. The other one is a binary search. Linear search is a concept where we start searching for the element from the beginning of array till the end, or from the end to the beginning, or till we get that number from the beginning or from the end. It is linear. One by one we start searching. That is logically, this is a very simple logic to solve the problem. Let us see how it works. Common lines. Accepting f(n) 10 elements. Number to be searched accepted. I is equal to 0. I is less than 10. I plus plus. So here, once again, I starts from 0. In the 0 position, we check whether the numbers to be searched is there or not. If it matches, we make k is equal to 1. Means the number exists. See, k is 0 in the beginning, assuming that the number does not exist. When it exists, k becomes 1. So loop goes on till the end. If anywhere the number matches, then only k becomes 1. At least one time the number exists, k becomes 1. Otherwise, k will remain 0 till the end. Once the loop completes, if k is equal to 1, means somewhere the number has matched. If k is 1, the number is present, otherwise number is not present. Simple logic, no? Accepting 10 numbers, accept number to be searched. Once again the loop, start searching the beginning till the end, anywhere it matches, make k is equal to 1. And if k is 1 when you come out of it, means the number present, otherwise number does not exist. It looks odd. If the number exists in the beginning only, k becomes 1 in the beginning only. Still we keep on repeating. Why should I repeat? So what you can do, after this, open the flower bracket before k is equal to 1 and put a break and close the flower bracket. Means that is for the if statement. Means if it matches, make k is 1 and break. Come out of the loop. Why should we waste further repetition of the loop? Right? So k is 1 and break. Both should be in the flower bracket, because only the condition is satisfied, we want to do it. The one way we can change. Or the question can be modified as count how many times a number exists. If you change the question like that, then you don't initialize k is equal to 1 here, you make it as k plus plus. So whenever the number matches, then we increase. For example, in the exam, out of my 10 students, how many got 100? I entered all my 10 students' marks. Then I want to see how many got 100. Then I just, whenever I is equal to 100, I had to increase the count. I don't want to say that 100 exists or not. How many hundreds exist? So I will make it as k plus plus. Right? Then what I should do here? If k is greater than or equal to 1, means at least one student is there or more than, then I say number present are k times. Otherwise number not present. So like that question can be changed in various ways. This also is a board question. It's a very simple program, right? It's a linear search. Start searching from the beginning. Check anywhere it matches. Simple logic. Now, bit difficult logic is here now. Same program. Write a program to accept 10 different numbers in a single dimensional array. Now enter number, and by using binary search technique, check whether number is present or not in the list of array elements. And the number, and by using binary search techniques, check whether the number binary search technique. If the number is present, then display message search successful. Only the number present successful, otherwise search unsuccessful. Exist successful, otherwise unsuccessful, like the last program, but it is a binary search. What is this binary search? So, see, we have 10 positions, right? 0 to 9 means 10 positions are there. Assume numbers are there like this. Numbers are there like this. Can you notice one property of these numbers? Yes. All these numbers in an array are in ascending order. Means for binary search, elements need to be in sorted order. That is very, very important for binary search. For example, you have a textbook. Pages are in order. So when you want to open some particular page, you will not start searching from the beginning, right? You will not turn one by one pages to come to your page. You just, where it may exist. You turn to that page directly, or if it is not what you are searching for, you may leave either this part or that part, and you start searching faster. You understand how you search on your own. Analyze how you are searching. Same thing will work out even here. See, some numbers are missing here, not like our page numbers. Some numbers are missing, but they are in order. When they are in order, the lower limit of this my array is 0 position. Upper limit of my array is 9 position. So I say lower bound is 0 and upper bound is 9 in this case. Right? Now, I will not search from the beginning or from the end. I want to know the middle position of this entire array. For example, assume I am searching for 65. Then, I don't know whether the number exists. I don't know whether the number exists or not. But I take the lower bound value plus the upper bound value, divide by 2. Take the integer part of it. 0 plus 9 is 9. 9 by 2 is 4. Is integer by integer division. It is only 4. Don't take it as 4.5. So now come and check in the fourth position. If a fourth position value, if it is matches what I am searching for, yes, it is, you are successful in searching. You can come out of it. If not, I am searching for 55, which is not equal to this number. Then I check in this position, is the number what I am searching is greater than this or less than this. If I am searching for the number is less than this position, then if it exists, it should exist in this side, right? Then I would have changed the upper bound 1 less than the middle position value. Or what I am searching for is bigger than this. If the number exists, it should exist in this side. So in such a case, I change the lower limit 1 more than the middle position value. Like this, either I can change the upper bound this side or lower bound this side. This process continues till we get the number, or when the lower bound crosses the upper bound. Let us see how a program works. Class B search, common lines. See, lower bound is 0, upper bound is 9, because there are 10 elements in the array. We accepted 10 elements in an array now. Once you accept 10 numbers, accept a number to be searched is also done. After accepting number to be searched, see, we check whether the lower bound is less than or equal to upper bound. My lower bound is 0, upper bound is 9. Yes, less than 0 is less than 9. Condition is satisfied. I'll just use this logic. Same thing, lines are rearranged. P is a position. P is equal to LB plus UB by 2. Take the middle position like how I said before. 0 plus 9 is 9. 9 by 2 is 5. Now, if M of P, M is an array name, P is a position. P is 4. So, in fourth position value, E is the number what I am searching for. Assume I am searching for 48 itself. Yes. Fourth position also 48 is there. NS also 48. Both of them are matched. I make K is equal to 1 and I break. I come out of the loop. Because we got the number. K was 0. K becomes 1. And we come out of the loop. And if K is 1, yes, K is 1. Search is successful. That's what we print. But if the number is not matching, I go to else part. And here I check, assume I'm searching for 25. Which does not exist. But if, then what we do? If M of P is 48, is less than what I'm searching for. Actually, I'm searching for 58 you assume. Then here it is 48 is there. Yes, 48 is less than what I'm searching for. I'm searching for 58. Yes, it is less than 58. So that is the case. What we do, we know that number exists in this side, then if it exists, right? I should change the lower bound from 0 to 1 more than this middle value, because middle value anyway is not matching. So lower bound is equal to P plus 1. This becomes 5. Means my lower bound becomes 5 because I am searching for 58, which is more than 48. If not, I am searching for, as I said, 28. Then what happens? My middle value is not less than what I am searching for. My middle value is greater than what I am searching for. So if the number exists, should exist this side. So upper bound is shifted. See, upper bound is equal to P minus 1. Upper bound comes this side. Is it right? So that like that position, either the lower bound or an upper bound will change when it is not matching. If suddenly we skipped around 4 terms. If it is 5,000 elements in an array or 10,000 elements in an array, at one stretch we skip half of the total length of an array for the first time. See, searching becomes so fast when the number of elements are more. But the drawback is the elements need to be in sorted order. Now, once again, when we go back, we check whether the lower bound is less than equal to upper bound. If satisfies, for example, as I said, I am searching for 28, you assume, and my upper bound has come over here. So it is 0 and 3. Lower bound is 0, upper bound is 3. If I add both of them and divide by 2, it is 1. Lower bound plus upper bound by 2 is 3 by 2 is 1. P is 1. Is it the number searching for is 33? No. And the number in this position is less than 28. This position value is not less than 28. So this lower bound is 33 is not less than this. So now it comes to this part once again. P is equal to, UB is equal to P minus 1. Once again this will come over here. Because the element what I am searching for is less than this. Right? So both my lower bound and upper bound has become 0 now. When I go back, they are equal. 0 plus 0 is 0, 0 by 2 is 0, means that my P also becomes 0. If M of P is equal to NS, I am searching for 28. 28 is not this. If M of P, this is 23, yes, less than what I am searching for 28. So, if satisfied, lower bound should be P plus 1. P is already 0. 0 plus 1 means 1. So, lower bound has become 1. Upper bound has become 0, means they cross each other, right? Lower bound has come further, whereas upper bound has went to the left side and lower bound has come to the right side, means the condition is not satisfied and I go next time. As a result, we come out of the loop. Once we come out of the loop, K remains 0 only. So then we say search is unsuccessful. So if the number exists, K becomes 1 and we break. If the number does not exist, this condition we satisfy. Lower bound is lower, upper bound will not satisfy at one case. Then we come out and we say number does not exist. So write the same program either this way or this. Both are same. Order of this is search it. I prefer this order. Maybe searching logic will be easy here. Okay. Go through and write and practice this program. Understand the logic once again. If you want, you replay the audio once again. Now we finished searching, selections, linear search and binary search. We must know the difference between linear search and binary search. That is the important thing. and both the programs. Then we have a sorting techniques, means when so many numbers are there or elements are there in an array, we need to put them in an order. When you want to put them in an order, we have so many techniques. So for us, we should know two sorting techniques. One is selection sort, the other one is a bubble sort. Selection sort and a bubble sort. Let us see how a selection sort works. This is a selection sort we are going to do now. Assume there are 8 elements in my array. These are my elements. They are not in order. These are the positions or index or a subscript. Now, I want to select the smallest number and put it in the beginning. Right? That's my first condition. I have to put the smallest number over here. How to get the smallest number? Search the entire array where the smaller number exists. Shift them like this. Once the smallest number comes over here, I want to get the second smallest number over here. Further onwards you check where the second smallest number, it is here. Shift these two. Third position, I want to get the third smallest number. Further you check. Yes, this is less than this. This is smallest. Shift them. Now here, fourth position. Further, leave this. Further you check. Yes, it is less. Shift them. Then here, this will exchange. Here, this will exchange. Here, no. Here, 89. This will not exchange. It will remain as such. Are you getting it? So, when I want to get the smallest number over here, first let me assume this is the smallest number. See, my outer loop should point over here. We'll have two loops here. Outer loop should point over here. And I assume this is the smallest number. Inner loop should start from this position. Check with this. No. Here, check with this. No. Inner loop is continuing. No. No. Here, yes. Means don't exchange. Till now we were assuming this number is the smallest number. No. Now we realize that this is smaller than this. So remember this position in at variable. And now onwards, when the inner loop repeats, compare with this position value. This position value compare. Still this is less than this. Remember this position. Continue further. Program loop, inner loop ends. When the inner loop ends, we have a position over here. These two positions value we need to exchange. How to exchange? Directly if I copy this over here, this will be overwritten. Or if I shift it over here directly, this will be overwritten. So I take a temporary variable, I shift this to temporary location, then I can shift this over here and the temporary value over here. Is it right? Let us see how this program works. Now, here the program is there. Import Java, selection sort, declared an array of size 10, accepting. See, till here it is the same thing. Then, for I is equal to 0, as I said, outer loop. I want to get the smallest number in 0 position now. I is equal to 0, I is less than 9. Not less than 10. It is less than 9. I'll explain later why. I plus plus. First time the condition is satisfied because I is 0. Then we make P is equal to I. The position is equal to I. I assume there itself the smaller number exists. As of now, my assumption is in the same position the smaller number exists. So this P stands for position where the smaller number exists. As of now, in the same position. Inner loop starts from next position onwards. See, J is equal to I plus 1. As I said, we must start searching further. So J becomes I plus 1. Means since I is 0, J starts from 1, goes till 9, less than 10 here. Right? So now what happens when J is 1? It checks with the J value, J position value, means first position value is less than, in this case P is 0 now, is less than 0 position value. Right? As we have noticed before, here that is not satisfied. That is not satisfied. So that is not satisfied. We will not, this J is here, P is here, that is not satisfied, nothing will happen, nothing. When it comes over here, yes. When it comes over there, that position value, the new position value is less than this P position value. So now you have to remember this J as a position of the smallest number position. So P becomes J. Position, the smallest number is P. For the next element, as you know, once again the next number is smaller than the previous position. Once again P changes. The loop completes in this process. Once the loop completes, my P will be pointing to the smallest number position. P is not the smallest number position with a smaller number exists. So as I showed here, the smallest number position is 6. P is pointing here now. It was pointing 0 in the beginning, then it becomes 5, then it becomes 6, and the loop gets over. Now we are supposed to exchange these two. That is done in the outer loop. The loop gets over. As I said, in temporary location, I copy that number. The 0 position value, I am copying in temporary location. Now in the 0 position, I shift the 6 position value. In the 6th position, I bring the number, what is the 0 position, that I shift over here. First, for 0 position value, I am copying in temporary location. Then in the 0 position, I am bringing the smallest position value. The smallest position value, I am copying the first value because that is there in T now. That's what is the logic here. Now, once we know this is shifted to the temporary, this has come over here, then this is shifted over here. That is the reason a temporary variable is required. Then goes back, I becomes 1. Right? Only the smallest number has come out. Now it is the second smallest number in first position. So P becomes I. J start from further onwards, next position onwards. It goes till the end. If anywhere it matches, it is less than that, P will change. Once the inner loop gets over, means second smallest number position is there in P, then like last time we exchange the second position value. Actually, index wise it is first, and the position with the smaller number exists, and the process continues like this. It is selectioning the smallest number in an array in the remaining elements, then bringing them to the position where we want to get that value. Once this is done, we have to print the sorted array. So numbers are in ascending order are I is equal to 0, I is less than 10, and I plus plus. It prints all the numbers one by one here. Is it right? All the elements are displayed. So this is a very, very important logic. See, 2 times it has appeared, more than 2 times it has appeared. Understand this logic, write and practice this program. It is a selection sort program. By chance, same program if they ask on strings. So you declare the string type, accept strings instead of next int, next line. Then this is same line, this is same, this is same. Here you cannot write just a less than symbol. You can say m of j, same position, dot compare to. Say as I said, compare to function is used to compare the ASCII values. Use dot compare to m of p means it is p, you write. Because you use min use otherwise p less than 0, starting ascending order. So this is the line you have to change if it is a string array, because question can come on strings even. Then this t is a temporary variable of string type, and you can print. This is compare to, you have to use. You cannot use directly a less than symbol. Is it okay? It is a selection sort. Go through once again, write and practice. Next one is a bubble sort. It is simple compared to our selection sort, because here the logic is a bit different. You have to compare 2 successive elements, these 2 positions. If the new position value, next position value is less than the previous position value, immediately you need to exchange. So 6 will come this side, 9 will come over here. Now 9 and 24. See, 24 is bigger than 9. No change, should not change. See, immediately it is changing. Then 24 and 3. Yes, 3 is less than 24, no? Immediately these two should change. See, only 3 and 24 has changed. 3 has not gone till here. Only this 3 has come here, 24 has come here. 24 and 11. successive elements. So 24 comes here, 11 comes here, 24 is here. Then inner loop, this and the next position. If it is inner loop is j and j plus 1 positions. Yes, j plus 1 value is greater than this, don't change. Now this becomes j. Inner loop increase. No? This and this. When it compare these two, yes, this is less than this. So interchange. Now these two, yes, interchange. So that the biggest number has bubbled out. Biggest number has bubbled out in this process. Is it clear? So it is the inner loop variable and the next position value. Compare, immediately you interchange. So once the inner loop completely gets over, we got the biggest number has bubbled out. Other numbers are not in order. Whereas the selection sort, when the inner loop completes first time, we would have got the smallest number over here. Here the biggest number has bubbled out. So next time when you are starting here in bubble sort, you must start from the beginning only, but you can skip the last element. Right? You have to go till here. Next time you can skip the last two elements, but you start from 0 only always. So this is the concept of a bubble sort. Let us see how it works out. Right? Hope you understand the concept. Inner loop variable, successive checking, and j plus 1 checking, immediate interchange if it is required. Let us see the program. It is a bubble sort program. This also appeared more than once. Public static scanner declared accepted elements. See, now sorting, no? In selection and bubble, both of them, I is equal to 0, I is less than 9 only. I is less than 9 only. J should start from 0, whereas there J was starting from I plus 1. Before the min was there, or P is equal to I was there. Here it is not necessary to remember the position because immediately we are exchanging it. So J is equal to 0. J is less than 9 minus I. So it is not less than 10. It is 9 minus I. So here, first time I is 0 means less than 9. Means J can go only up to 8 position. Let us see why. So 0 can first time it satisfied. 0 and first position value. If 0 position value is greater than the first position value, right? 0 position value is greater than the first position value means you need to exchange. So 0 position value, take it to temporary. In the 0 position, put the first value. In the first position, the temporary value exchange. So elements are exchanged if j is greater than j plus 1 means previous element is greater than the next element. Exchanging is done in the inner loop. J is incremented, right? Takes the next position. That and the next element. Those two. If it is required, we exchange. Like that, the inner loop each time comparison between j and j plus 1. As a result, when j becomes 8, 8 is less than 9. 8th position and the 9th position is compared. When the last position is compared when j reaches 8 itself. So you should go less than 9 minus y. Because if I go up to less than 9 or less than 10, then j becomes 9, then this try to become 10. 10th position does not exist, it gives an error message. So you should go less than 9 minus I only. Because next time, when the inner loop gets over, the first number, biggest number has bubbled out. So no need to go to the last position. So we are skipping how many times the outer loop has completed, so many elements are bubbled out. We can skip so many elements from the right side. So it is 9 minus I. Like that, elements, first time all the elements are exchanged, bubbled out. Then when I becomes 1, once again j starts from 0 only, but this time it goes only up to 7th position, means 7th and 8th, till the 7th and 8th positions values are compared. Think where they will be exchanged. Like that, the outer loop, inner loop complete continues and all the numbers will be sorted out. Remember, till here for selection and bubble it is same. There is remember P is equal to I. Here not necessary because we are exchanging the inner loop itself. There we are exchanging the outer loop. This line is same, no need to write that line. Here j should start from 0 less than 9 minus I. There j should start from I plus 1 less than 10 we used to write. There we used to compare p value with the j value. Here j and j plus 1. No need to have one more extra variable. Immediately you interchange these two values required. So program itself gets over in this. Go through. If you have the strings, then same thing, use compare to function here. If it is strings. Instead of ascending order, it has descending order, change this sign. So greater than, make it as less than sign. So these are the simple things you have to remember. Very, very important program, selection sort, bubble sort, binary search, linear search. Most of the time, one of these programs will come, maybe tested in different formats, but logic is the same. Now, let us work on some strings and arrays. See, word question. Go to the question. Here, he wants to accept the 10 cities names randomly, but arrange them in order using a bubble sort. See, the strings. So, bubble sort, common line, string array, temporary as a string variable, loop, 10 times the loop repeats, 10 number names are accepted, 10 city names are accepted. Bubble sort, no? So there are 10. See, I is equal to 0, I is less than 9. J is equal to 0. J is less than 9 minus I, J plus plus. Same program as before. And if city is city, no? City of J compared to city of J plus 1 greater than 0. That already we wrote it over there, no? J and J plus 1. T is equal to city of J. City of J is equal to city of J plus 1. This should come inside the bracket. City of J plus 1, this should come inside here, is equal to T. Exchanging is the same. Only we have to use compare to function for comparing it. Like in your class, if there are 40 students, the class, you want to put the name in alphabetical order, then you can use this program to arrange the names in alphabetical order. This also has come once. See, at least 3 years, in last 10 years, bubble sort has come. Then it is printing the elements, printing the arrays after sorting it out. These are important programs. Now, go to the question. Question says, we need to have two single dimensional array of size 10 each, one to store 10 state names, one more to store its respective capitals. Right? So we have to have two single dimensional arrays of string type. So only he has declared two string arrays of size 10 here. Till here is more or less same. Then we have to take one state, accept a state name, and its respective capital should be printed if it exists. What type of search it is? It is a linear search, right? Let us start searching. So now what we did? We declared both the arrays. Loop started. We started getting the name of the state and its respective capital. Name in M of I, capital in N of I. Like that the loop repeats. Actually, when you are working, you accept it, and immediately what you do is accept all the 10s, then you enter the state whose capital to be slash, that also you accept. Are you getting it? 10 state name with the respective capital names. Then one more state name you are accepting it here. After accepting it, for I is equal to 0, I is less than 10. If M of I equals ignore case st. See, M of I dot equals ignore case xt. We are checking with M array. M has a state names. It is equal to the ignore case of st. The state name what is entered later by us for searching. If it never matches, linear search, but it is a string, so equal ignore case function you are using. K is equal to 1. You remember? K is equal to 1 with a linear search. he is not breaking. But he wants to remember, since he is not breaking, he goes further to the last position. So you must remember where the state exists, in which position. So A is equal to I. He will try to remember the position where the state name exists. See, both the lines are important here. Position is also important. Once the loop gets over, if K is 1, means it exists. State name exists. Where? That is in the A position. No? So respective capital we have to print. Capital is N of A. Respect the respective capital name over here. So N of A. So A is required because we are going till the end. Otherwise, you make K is equal to 1 and you can break here itself. If you break, when K is equal to 1, you can say N of I only because we are breaking when it exists. There only we are breaking, no? So you can write N of I. Otherwise, you can say it does not exist. But generally, this is a logic, a linear search, but on strings, searching from one array and displaying from the second array. See how nice the concepts are covered over here. So can come like this. Go to the program or play the video one more time. Now go to this program. You are supposed to accept 10 names. Fine, like how we did all these programs. Not necessarily always 10. You can change to 5 or 10 or 20, whatever it is. Accept 10 names in this case. So you have to declare an array of size 10. Then accept only one character. Then print those names which are starting with that character is the question. See, once again it is searching. After getting it, you cannot come out of it. You must continue till the end, right? So all these lines are common. Name to take 10 names. String array is declared. The loop repeats 10 times, means 10 names are accepted. Then enter the first character whose name to be searched. See, only one character you need to accept. CHR is equal to in.next.caret0. You take only one character here. Once you take only one character, see, loop starts for I is equal to 0, I is less than 10 because there are 10 names. What it did? B is equal to nm of I. Nm is an array name. I is first time 0, means first name is taken into B. If B dot caret 0, that name, first character is equal to the character what I am searching for is there. Since again linear search, if there, print that name because I want to print who is starting from A here, right? So you have to immediately print and increase the count by 1. Instead of writing C is equal to C plus 1, you can just write C plus plus. Is an inner loop. Then out loop, if the loop also gets over here. So like this, 10 times the loop repeats. Next names are taken. Their 0th position character is checked with character to be checked. Matches display that full name. Increase the count. If C is equal to 0 once the entire loop gets over, means there is no name starting with that, then you should not come out without giving any proper message. No, you can say no name is found, right? No name does not exist. This is a message. If they know there is no name starting with that character, if anywhere it matches, that name is displayed. Since C will be more than 0, then this part will not execute. Right? Hope you understand logic. Only thing I felt is instead of writing this line, directly they would have written if nm of I dot caret 0 is equal to chr. No need to take this variable, extra variable over here. It is a linear searching, but you cannot break at a continuum. It is on strings, but comparing with one particular character here. How to accept the character is known to us always. So these are the programs. Understand the program. If you understand this much, you can write any program in this single dimensional array, and it is usually 15 marks. One question is going to come. You can definitely get that program, especially selection sort, buffer sort program. You must be thorough. Is it okay? All the best. Practice.